Welcome to this topic video on web sessions. So, references, session management cheat sheet. Okay, this is more than just a cheat sheet. It's a good introduction. It provides clear definitions and discusses the need for sessions and their security issues. So what is a web session? A web session is a sequence of network HTTP request and response transactions associated with the same user. Modern and complex web applications require retaining information or status about each user for the duration of multiple HTTP requests. Okay? We interact with a website, with our web apps, with multiple requests and responses. Okay? We need some kind of state. HTTP is stateless. Okay, it doesn't remember things. Sessions provide this ability to establish variables, such as access rights, variables, general information, general state, such as access rights and localization settings, okay, which can apply to each and every interaction a user has with the website for the duration of the session, okay. HTTP is stateless. The protocol itself doesn't have anything in it, right? We just learned about cookies, which was a supplement, okay, that keeps some information in a browser to help us have some state, okay? So we have a need for sessions. A web application may need to keep state about users, such as preferences. Are you logged in? Privileges? Are you a super user? Are you an admin? Etc. Shopping carts? Etc. Okay. And we've seen cookies provide one way of keeping application state. Okay. So now we're going to delve in more deeply. The question now is who should store the state? Okay. We could make clients store state by putting all the relevant state information into a cookie or similar mechanism. Okay, there are better mechanisms in cookies nowadays for browser storage. There's some quite good ones. Okay, if there is a significant amount of state, this method can be quite inefficient because you'd have to send it all back up to the server for the server to do things. Okay, you could have the server store state and identify that state with a unique session identifier. Okay, that the server uses to look up the application state. Such a session identifier can be kept in a cookie. Okay, this is much more efficient when there is lots of state. Okay, so we don't store the information directly in a cookie. We keep the information on the server and we label it with a unique session identifier. So when a request comes in, we can use the session identifier in the cookie to look up the state on the server. This is the approach we're going to take in this class. Okay? It's not the only one. Web applications can create sessions to keep track of anonymous users after the very first user request. An example would be maintaining user language preferences or keeping track of what pages they visit. Let's see what their interests are. Additionally, web applications will make use of sessions once the user has authenticated. Okay, once they have logged in. Okay, this ensures the ability to identify the user on subsequent requests. Okay, and applies security access controls. This is why this gets very important for us to know how to do right. Okay, authorize access to private data and decrease the usability. Okay, it's no fun to have to keep logging in every time. Okay, that's really known as authenticate every request. Okay, it's used in APIs. What do I mean by APIs? Machine-to-machine interfaces. Okay. So, for example, if you're using some service from some server your server talks to some service was offered on another service, your requests to that server will probably have special authorization authentication keys in it, okay, and such like that, okay. That's going from machine to machine. No big deal. Asking a user to retype something to authenticate themselves with every transaction is not appropriate for user interfaces, okay. The other approach establishes a server-based session tied to that of a session ID that lasts a given period of time. Okay, that's what we're doing in this class. Or you can keep credentials in a secure token. Okay, this is known as JWT, JSON Web Tokens. We're not going to handle that here. Similar concepts, different implementation, and you keep credentials. A little different than a session ID in one of these things that gets carried around and requests, but not as a. Okay, here's the big danger. Once an authenticated session has been established, okay, so once you've logged in, the session ID is temporarily equivalent to the strongest authentication method used by the application. So that's great you're using two-factor identification, or that's great you got a super long password and you obeyed every password rule, okay? However, once you've logged in, that session ID is equivalent, okay, to the strongest method that you use, okay? That means people go after these session IDs, okay? So they are something that people are going to attack. So what do these implementations look like? Okay, so who does what? Servers generate session IDs and session state. What's in that state? It depends on what your site's doing. You want to just count how many times that user comes back? You just keep a little counter for that user. Okay, got a shopping cart? Yeah. Can keep track of their preference, like their languages? Great. Okay, that's the state piece. That could also indicate whether they're logged in. Okay, so it generates the session IDs. It retrieves the session state based on the session ID from some kind of session storage, and it delivers it to the server application, okay, for use. Okay, so when we write our server code, we got those handlers, okay, that do things based on path and method, right? We have a get method and we have a particular path. We'll have a callback function that'll deal with that. We want something to help us, or something to hand us that session state to use in those handler functions, okay? So we can do things based on information about the visitors, okay? The other thing the server is responsible of is removing the session state and retiring the session ID when the session ends, okay? So when the session is over, okay? The big responsibility on top of those other things is ensuring the security of session IDs, okay? We're making secure multi-user websites, okay? We've got to do this right. Okay, so what's the server block diagram? Okay, a request, an HTTP request comes in, okay, and we're going to store our session ID with our in a cookie. So the request is going to carry this cookie in there, the session ID, okay. Oh, you then use that session ID you received to look up session state in the data store, okay. You hand that off or attach it with the request as you pass that request other things. Professor, yeah. This sounds like something you might do with middleware. Oh, you notice that, yeah. Then you might have some of your own middleware to do access control. Oh, I get it. So this is going to be part of the processing chain. A request goes through, okay, and then we're going to, so that's going to be some middleware. That's going to be probably that we get from somebody that's been well tested and well thought through for security purposes, then we're going to add our access control because only we understand it. Okay. And then we're going to handle the rest of things. Okay. That only we know what to do because it's our app, our server. Okay. The server will keep state about a session. Okay. A session's a set of interactions with the client, but they'll keep information about it. Okay. The state will be associated with the session ID. Okay. The thing about state is this is what you are going to be defining. Okay. One of the most simple things that we're going to do for our app is we're going to define whether a user is logged in and what their role is. Okay. The state that is associated with the session ID will be, the session ID will be sent in a cookie. Okay. So that's how we're going to let the client know the session ID. The cookie with the session ID gets sent from the client on every subsequent request to the server. Oh, so that's how we can recover the session state and update the session state. We'll know if they've got a shopping cart. We'll know what to put in the shopping cart with every transaction. Yes, exactly. Okay. We're the ones who decide what that session information will be. Okay, and that's sometimes confusing when you see little examples of session middleware. They'll show you an example, and it's like, I don't care about visit counting, and they'll show you an example where the only session state they may have kept was a count of number of times that person had visited that site. Okay, it's up to us to decide these things. Okay, login status being most important. Okay, they're not even going to care about login. We are going to process logins. Okay, session information is not kept in the cookie. It's only the session ID. The session information, the session state, is kept on the server. Okay, the server will have a data store. Okay, database, in-memory thing, whatever. Okay, object relational, doesn't matter. Okay, to map session IDs to session state. Okay. Example. Simplest login example. An initial state for a visitor coming in. What all keep track of? Are they logged in? What's the initial state I'll have for them? False. After they log in, I'll have logged in true. First name, last name, whatever we want to keep about the user or that's useful for us to keep there that we wouldn't already know. Okay. Let's understand this. To help us understand this, we're going to use something known as a sequence chart or a message sequence chart. Okay. These things have been used often in software and protocol specifications. Sometimes they can get overly formal about how they write them up. Okay. I use this one nice free resource on the web to construct the sequence diagrams that you're going to be seeing. So how do these diagrams work? Okay, you have an arrow that shows a message going from one place to another. What's not shown here is time advances downward. Okay, so the browser is going to have an initial visit to this website. The server receives that request. Okay, after it first receives that request, it's going to establish a new session state in the session store. Okay, such as logged in false, user null. Okay, that's going to associate that state with a new session ID. In the response back, it's going to use the set cookie header with the session with a cookie that contains the session ID. Okay, that's session establishment, and that's the order of operations. Browser, initial visit, message. Time passing, well, you're going to do this on the server, then we do that on the server, then we send a message back. That's why I like message sequence charts for looking at this stuff. It made it a lot clearer to me, hopefully to you. Okay, So what if you're not logged in and you try and visit a protected asset? What happens? Well, you got a request, okay? Say you want to see all the users, okay? Now you got a cookie because you visited before, okay? The server receives your request. It looks up the session state in store. It sees that you're not logged in. The user is null. It says, wait a second, you're not logged in. You want a list of all the users on the site? Ain't gonna send it to you. You must log in. It'll respond with some kind of forbidden message, okay? Or tell you to log in or something of that effect, depending on your application, okay? How would login proceed? Okay, login, let's say we have a form, okay? We're gonna use or let's say we just use a post request with information, okay? So request, login, post, okay? The information, email and password, okay? We've got this previous session ID, okay? So all this information comes in. We look up, say, the email and password in the database, okay? If we can verify the password, we're going to update the session state and ID, okay? We'll actually make sure we generate a new session ID, okay? There's a reason for that, okay? And we'll update the session state and such like that and send back a new session ID that'll be associated with this new advanced state for the user, okay? They're logged in, visitor, that is. Okay, now, suppose somebody wants to visit a protected asset or get information. The browser sends a request. Okay, say it wants to see a list of the users for some reason or something or other. Okay, cookie's got the session ID. Server once again looks up the session state in its storage. This time we see they're logged in. It's true. We have the user information. The application checks that the user is logged in, which you can easily see in the state, then creates the page or sends back JSON assets, okay? So we can get the assets, okay? Those are the processing things we're going to do. Now, how are sessions protected? Okay, people would like to find out the session ID. They'd like to be able to capture it, predict it, brute force guess it, or stop it from changing so they know what's the next one's going to be, okay? Anything they can do to get at those session IDs, okay? They call hijacking, sidejacking attacks, okay? Where an attacker is able, if they get that session ID, they're able to impersonate the victim, the user of the web app, okay? So they're going to be going after that session ID. Okay, so how are we going to do this? We have the session identifier, okay? That's the sign of session creation. It's shared, okay? It has to be sent on every HTTP request, okay? First of all, length, like a password, but more so. It's got to be long enough to prevent brute force attacks. Current recommendations are 16 bytes or more, okay? Entropy. Entropy? Is this a statistical mechanics class? Huh? Entropy? No. The session ID must be unpredictable, random enough so it can't be guessed. Okay? For that, we have to use, remember we learned about these? Cryptographically strong random numbers. Not math.random like you used in simulations, okay? But cryptographically strong from real sources of randomness. Oh, okay. Content. The content must be meaningless to prevent disclosure type of attacks. Oh, I'm going to come up with some really cool hidden content. No. If your site's worth for people going after the session, you've got to be meaningless. Okay. So figure out ways to go after it. Okay, recommendations. Okay, session IDs are passed in the form of name-value pairs. They're passed in the cookies. The names given by popular web frameworks are well known. The detection of one of these names gives an attacker additional information. Okay? Change the default name, okay, used by your framework. We're going to be able to do that with express sessions. Okay? Make it unique. Okay? Make it fun. I don't care. But don't use the default name from your framework. Okay. Transporting. We're going to be using HTTP cookies to transport our session IDs. Okay? Because of this, in any deployment, you have to use HTTPS. This doesn't work. Browsers will properly tell you if somebody's submitting stuff, login information, okay, or whatever, that there's a problem, okay? We're the ones, though, that need to understand that session IDs have to be transported, okay, over HTTPS, okay? Because otherwise, it can be seen by people that have access to the network, okay? I'm not saying that's an easy thing necessarily, but from the network perspective, if you're on the network, if you're dealing with pieces of equipment in the network, it's really easy to see this stuff go by, okay? Okay, so what are we going to do? We're going to set some cookie attributes. Secure. What does this do? This tells the browser, remember, it's the browser that sends this back to the server. This tells the browser never ever send, okay, never ever send this cookie over an insecure connection. Okay, it's got to be HTTPS. The browser knows, right? You can see up here, well, not here, okay, if it's a secure connection. The browser won't send it. Another thing to prevent other types of attacks is you make the cookie that's carrying the session ID HTTP only, okay? That way JavaScript doesn't have access to the cookie. I know we're writing apps. We really have no reason to be looking at the cookie, okay? Or at least the cookie containing the session ID, okay? No reason our web app, our JavaScript that's running in the browser needs to look at the cookie, okay? This is only for getting our sessions, keeping, okay? Same site, makes it, helps it against cross-site requests and cross-site scripting type of attacks. Domain and path, where possible, use a restricted domain and restricted path. Expire these things, okay? Expire these things. Note, many browsers provide session restore. So any advice to use session cookies is somewhat dated, okay? We want to make sure that cookies disappear from the browser in some fashion, okay? And we'll see how to do that, okay? Actually, I should say Express makes it easy to do that. Okay, so what's the session ID lifecycle? Okay, web applications never accept a session ID that they never generated. Good. In case you're receiving one, should generate and offer the user a new one, valid, and that's suspicious activity. Okay, so this is a kind of thing that should be logged. Okay. Okay. Manage when you get session IDs. Right, we're getting them in HTTP. We're getting them as part of the request messages in the cookies. Consider them untrusted. Okay, run them through all the checks and validation and things like that. Okay, gee, Professor, this sounds like a lot. Yeah. Okay. Renew the session ID after any privilege level change. One of the most popular attacks, well, I shouldn't say most popular. The most popular attack is going after WordPress admin passwords that haven't been changed by script kiddies. Okay, because those are the ones I see all the time on my website. And no, I don't want to run WordPress. Okay, it's an elevation of privilege attack. Okay, and so to prevent those kind of attacks, what they say is the session ID must be renewed or regenerated, changed, okay, by the web application, the server, after any privilege level change. For us, where are we going to do that? after login. How are we going to do that? There's going to be some tools to help us from the middleware. Yes, we're going to use a nice piece of middleware to help us do all of these things. Every one of these recommendations will be handled partially in the middleware and partially by us. Okay. To minimize the time period an attacker can launch attacks over hacker sessions, it's mandatory to set expiration timeouts for every session. Have you ever noticed that you're on your website, some website you're visiting, and you're hanging there for a long time, and all of a sudden they ask you to re-log in? Yep. Yeah, because it's good. They're expiring the session. Okay. Now, how quickly they expire it depends on what kind of website you're visiting and how sensitive the data is. If you're at a banking website, it's going to expire relatively quickly. They will warn you of that relatively quickly. If you're at a learning management system, I don't know, they may give you half a day or so. I can't remember exactly. All right. Next thing we're going to learn, obviously, is how to actually implement this in our own Express-based servers using some middleware.